It's me, Red Planet, coming to you once again with another video. No rights to the video or music, strictly for educational purposes only. Let's hear him talk about this earthquake, the 6.9 earthquake. Let's get into it, Israel.
Hi everyone, breaking news, a 6.9 magnitude earthquake just ruptured along the Kermadec Tonga subduction zone here at Tafua Island. We see this is a volcano very clearly. This 6.9 magnitude earthquake ruptured at a depth of 106.7 kilometers. You'll see that there are two other earthquakes nearby. There was also a 6.1 magnitude earthquake and a magnitude 5.3 that all occurred in rapid succession. You see the time here, 23:29:08 UTC time for the 25th of August. And then about a minute later, that 6.1 ruptured, and just a few minutes after that, that 5.3, all at about 100 kilometers in depth, clearly indicating that this is due to subduction of the oceanic crust underneath the oceanic crust here at Kermadec Tonga subduction zone. If we switch over to our historic seismicity map, we see that as we move further away from that subduction zone, the earthquakes get deeper because that oceanic crust is subducting deeper and deeper into Earth's mantle. Here we see the extent of this magnitude 6.9 in terms of its intensity, a very significant earthquake. Now in Google Earth, we can see how these three earthquakes are clustered together around Tafua Island. Interesting that the epicenter for that is directly on the island, even though the hypocenter is 106 kilometers down. If we go just slightly to the south, though, we will see the Hunga Ha'apai volcano, which exploded with a VEI-2 eruption on January 15th, 2022. This is the biggest volcanic eruption that we've had in recent history, and it was so strong that it actually altered the characteristics of the global electric circuit. And so that is why this is such a significant development, because last time we saw a big volcanic eruption along this subduction zone with the Hunga Tonga eruption. It changed the electromagnetic properties of the Earth temporarily for a few hours, and then there were long-term changes to the climate because of those volcanic clouds that went way up above the troposphere and into the stratosphere, making winters in Europe colder, winters in North America milder, and bringing overall more water and rain to North America, changing the climate across the world in many ways, though subtly. And those changes are still unraveling as we go through this decade. They're expected to kind of taper out and end around 2028, 2029. Here we're looking at the volcanic explosion that occurred at Hunga Ha'apai volcano on January 15th, 2022. This volcano submerged about 150 meters underwater, so it had to blast through that. That sent a lot of water vapor up into our atmosphere, more than we normally receive, because this was a big impulse of that. It was also a very significant electromagnetic impulse. We even saw that in our background electromagnetic spectrum on that day. Let's give it a look. We can understand how that 2022 Hunga Tonga eruption was able to leave an energetic imprint in the global electric circuit temporarily because of how explosive it was, just how massive it was. Here we have the before and the after, showing that it completely obliterated that island chain. Now, a lot of that island was underwater, but it just totally demolished it through a sequence of 5 explosions. And these explosions all had significant effects on the ionosphere, and we see that very clearly with this data here. Specifically, the main explosions number 2 and number 3, we see our total electron content of the ionosphere up top.
So it's only a matter of time. This Tonga, or whatever, earthquake, I think that's maybe in some part of Hawaii. It's only a matter of time before we have the big one. The big earthquake, because this is a 6.9. That's a big one, and you can imagine the aftershocks that they had along with this earthquake, many aftershocks. But this is getting ready to pop off, Israel, and we're headed for that big one that's going to be felt worldwide. That Everybody is going to feel that earthquake like a 20.6 or 20.2, 20.13 or 20.20 earthquake that's extremely big, that is felt everywhere. This is where we're headed. Now, this was a big one because this is a 6.9. And we have been having earthquakes, which brings on tsunamis, volcano eruptions. And if we can get a big earthquake, Israel, we get a big earthquake, it's going to kick off and pop off Yellowstone. When that happens, it's over. You might as well say it's pretty much over for us. Because that soot is going to hit everywhere, even here. That's how big Yellowstone is. And they don't want that to erupt because they know their pending doom is over anyway. But it'll really be over if that happens. But this is a big one, the 6.9. This caused some damage, I'm sure.
This is the overall amount of electrons that are in the ionosphere. Electrons having been liberated from different molecules, they are charge carriers. As a result, when there are more electrons in the ionosphere, it has a greater charge. Well, we see that there is a spike in the total electron content of the ionosphere, but then after those two main explosions, the total electron content dropped precipitously. And the reason why is because there was a significant amount of volcanic lightning that occurred during this explosion sequence, and that pulled in energy from the ionosphere because it created this highly ionized channel, and that created stronger background vertical electric field vibrations, specifically in the Schumann resonances. We can see that very clearly by looking at our data out of Hungary from a geophysical observatory there, way on the other side of the planet. And if we zoom in, we see this energetic imprint in the Schumann resonances right there, also in the magnetic component right here, east-west direction. And so this, just for reference, is a vertical electric field spectrogram going from 0 to 45 hertz. We're looking at the vibrations that exist in the vertical direction going from the ground surface up to the ionosphere. This is in Sopron, Hungary, very far away from the Hunga Tonga volcano, yet we still see this big burst of electrical activity there in our vertical electric field and also in our magnetic horizontal component, showing that there was just an overall energetic increase at that moment in time globally. In our recent history, we've seen quite a bit of activity along this subduction zone here, most notably with that January 15th, 2022 VEI-2 eruption at the Hunga Tonga Hunga Ha'apai volcano. And now we are seeing fresh activity as it relates to earthquakes with this magnitude 6.9 at 106.8 kilometers in depth, epicenter right at Tofua Island, which is a mean-looking volcano. You actually see it smoking there in the Google Earth imagery. This is just one small little outlet. Here is the larger caldera. And so this could be indicating new fresh flows of magma coming up from the mantle. That is what is creating these island volcanic chains. You have the subduction of the oceanic crust here, and then this causes different chemical reactions to occur. You get this upwelling of magma and energy, and eventually that releases itself in volcanic explosions. And so this is a big earthquake. There was clearly a lot of stress built up there, and then that release, likely the oceanic crust slipped finally, whereas it was kind of stuck before, and perhaps that will allow new flows of magma to come up. This is definitely an area to watch now that we've had this earthquake sequence here and knowing the history of this volcano. It didn't erupt just in January 15th of 2022. It also erupted in December the year prior, but this eruption was 7 times larger. That's the estimate. So I'll be tracking this area very closely, and in general, I track the energetic changes on our planet due to factors like solar activity and planetary resonances. If you'd like to stay up to date, then please subscribe to my channel. And if you like this content, please like the video, help this channel grow. I've been your host, Stefan Burns, wishing you well. I'll see you in the next one.